Hello, my name is Ron Patrick. I'm with ECM, Engine Control and Monitoring. This is a tutorial for ECM's Lambda sensor calibration system. This particular version is a 4-channel unit which will calibrate 4 Lambda or O2 sensors at once. These sensors are used in ECM's analyzers and modules, the Lambda 5220, the EGR 5230, and the Lambda CAN modules. The sensors used in these devices have a memory chip in this connector. Factory calibration and user cal is stored in here. So once you do this calibration, you can send this sensor to a location and your calibration will be retained. Sensor calibration with this device allows you to maintain consistency and traceability through a large test facility. The system consists of a rolling cart with a power supply, a baro can, it's the black module there, 2 sensors for the baro can, 4 Lambda cans in front, a display, and a Lambda sensor simulator and a pressure sensor simulator, which is here in the drawer, as well as a PC running the calibration software. Now a little bit about the Lambda sensor. The Lambda sensor or O2 sensor or wideband sensor or UAGO sensor, they're called different things, or linear O2 sensor, operates on a diffusion process. So size of little holes in the sensor determine its calibration. And as such, you can calibrate it with almost any gas. Air is the most handy gas to use. Also, due to the sensor's design, there is no zero drift, but there will be a gain drift, so the calibration simply consists of a span in air. So let's do that. First thing you do is you plug the unit into the wall and follow the instructions on the front panel. Right here. Number 1, switch on power strip and power supply, both on lower shelf. Click, click. The dash cam display should power up. Then press the on button on the PC. In less than 30 seconds, ECM's calibration tool software should boot up. If not, you can activate the software from this icon here on the display. So let's give it its 30 seconds to start up. There you go. Okie doke. Click on the Modules tab there, and then the Start button. Note the setting: Cavisor, leaf light, HS1 channel, and 500 kps. This is the setting for the configuration. So if somebody messes with it and moves it off, you can restore it. Click on the Start button. What you're going to see is it's going to find these modules here. Node OX20, OX10, OX30. It doesn't do it in order, but it should find a total of 5 modules. And the node IDs are written on a little label on top. So the Lambda can, it's 10. Here's the second one, 20, 30, 40, and the baro can is 50. All right. Now you connect 1, 2, 3, or 4 Lambda sensors to the cables that are labeled OX10, OX20, OX30, OX40. So OX10 will go to OX10 Lambda can. So you don't have to particularly, if you're just doing one sensor, put it on the first one. You can also put it on the fourth one, whatever. But I like to put them, if you have 3, go 1, 2, 3, or 4. The data from the first one, the O2 reading, will go on the top display. So I'm going to attach, I have 4 sensors here, and I'm going to attach them. Click. and you hang them here, they're going to get hot. Not immediately, but give it a couple minutes to get hot. So I like to put them here, hang them so they're not on the table or sitting against something plastic. Depending on which sensor you're calibrating, different types will have different cable lengths. And so with this system, you can handle all of them. There you go. All right, the sensors are on there. Now we're going to open the module menu right here and click down to all Lambda CAN and Lambda CAN P. There, okay? And automatically gives you the task span 02 for multiple modules. Wait 1 minute and then click on Reset 0 and Span. And I haven't quite waited a minute. Let's say, let's give another 15 seconds here. Now the sensors aren't ready to calibrate, but they are on, and the electronics and the Lambda CAN modules have a chance to see if the sensor is okay. There's no use calibrating a sensor that's failed. So, here we got our 15. So what you do is you click on the Reset 0 and Span, right there. You click on it, and in this field here, it states the progress, and after about 2 seconds, you see it says resetting node ID, 20's okay, 10's okay, 30's okay, and 40's okay. And that means that the Lambda CAN modules have not found any errors with the sensors. Now if you disconnect one of these, I'll disconnect this one here. So if a sensor isn't there and you do that Reset 0 and Span, you'll see that OX40 has error code OX14, which means open heater, which means there's something busted inside. So if you don't have a sensor on a cable, it'll give you that error. Don't worry, you can keep on going. You could just be calibrating 3. But if you had a sensor there that gave an error, you're wasting your time calibrating it. You know, throw the thing out. So I have some sensors here. This one has, this one's one with an open heater. I'm going to do this one first. So you put it on here. You got to wait. We got to wait until it's heated up. So we got to do a minute. And see, we don't wait a minute. What happens? Just for the heck of it. It might be give another code that the sensor's warming up. No, it gave a 14. Yeah, this one came up to temperature fast. A minute is just in case it's a cold room, the sensor's stone cold, whatever. Within a minute, it might take, you know, as little as 15 seconds. Okay, that one is an error code 14. So I think I'm belaboring the point by putting another one on it, which has a error 41. If you want to know what the errors are, right on here you can look in the manual, or you can click on this file, the Lambda CAN error codes, and here's the number, and this explains what it is. All right, so let's take off this bad sensor, and let's put on the good sensor. And clearly it's taking less than 1 minute for this one, so that's cool. So let's do Reset 0 and Span again. Boom, 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 boom. Oh, it's error code 01. That's the sensor is warming up, so that's good. I'm not waiting. I'm not patient enough, like many of you. All right, so all right. There, finally. Okay. So all read okay after about a minute. So that means you can continue. Like I said, if a sensor gives an error, unless the module, the cable's bad, and it usually isn't, it's the sensor's bad, so tag it, throw it out, save it next time you see us. But don't try to calibrate. It's a waste. Now you're going to wait 1 hour. Sometimes if a sensor has been used in the intake, for example, for an EGR meter, it'll be smoking for a while. So it might take longer, maybe up to 24 hours, until the thing stops smelling. And so after one hour, or after they stop smelling, which will be longer, you're going to span the sensor in the room air. But if you have a lot of wind in your room, it's going to make the calibration numbers jumpy. So what you can do is take a can like this, a clean one. Don't want to have one that's oily, because if you can smell oil or something, gasoline in there, the sensor can, so it's not seeing pure air. And then hang the sensor or sensors in there just to keep the wind off it. But the case here, we don't have any wind, so we're not going to need this can. So you can wait 1 hour or longer. For some sensors, it'll take 2 days before they stop smoking or smelling. Like I said, especially the intake O2 sensors for the EGR meter. Now we're going to do the span. You click in actual O2 in here. And the actual O2 is the percentage O2 in air as calculated by the Barrow can, which uses these two sensors. If you have no water vapor, the percentage O2 in air is 20.945, and as the humidity goes up, the percentage O2 goes down. Typical numbers are approximately 20.7, which is coincidentally exactly what we're getting here. So you type in 20.7, it should be moving around, and hopefully there's not the smoke from these sensors is confusing this thing. Everything should be nicely cleaned out. And you put 20.7 in there, and then you click span. This is going to take 10 seconds, so it's going to take 10 seconds of data, and it'll do its countdown, and after, it's going to say calibrating node ID for 20, 10, 30, 40. If everything's okay, it'll say okay. Now sometimes after waiting a couple hours, the sensor will pop a code. It's rare, but it can happen. Maybe it failed while it was hanging in air or something happened to it. So if it pops a code, throw it out. Also, you can roll down using here, you can roll down in this and look at the age factors for the sensors. That's the numbers here. See 0.96, 0.96, 0.96, 0.96. When the sensor is brand new and it's been calibrated by us, and you put it here and you hang it in air and water, hang it in air for 1 hour, it's going to be very close to an age factor of 1, which is like brand new, like 100%. As the sensor ages and you do the calibration, the number will go down, 0.96. When it gets down to about 0.8, we see this, the sensor's kind of ready to sign off. So although you can calibrate it and use it theoretically until it goes down to 0.5, it means the sensor's getting near end of life. So if you're going to have a long-term test or something, you're not going to see a sensor for a while, it's best just to retire the sensor. When the sensor cracks, it won't give an error code sometimes, and it'll show an age factor of 1.1, which means the signal's 10% higher. This is a common failure mode for what you see when the sensor cracks. So that sensor definitely tosses. So if you do a calibration and you see the age factor that's below 8.8 or above 1.1, throw the sensor out. Now you're finished. And so what you can do is disconnect the sensors, they're still hot, and you can distribute them for use. Now if you make a mistake while you're doing this, just reset the 0 and span again. Click. Hopefully you'll get everything's okay. And then you don't have to wait an hour if it's already been sitting. Do your span again. And this one, when we punch 20.7, we span, you'll see the first sensor before the span, it's showing 20.18, so it's slightly aged. It's 4, 3, 2, 1. Okay, the calibrations have done. Click. It's going to go up to very close to the target 20.7. Now, This last number here, O, is popping up and down, O1. Now we didn't wait 1 hour, so that's why it's going to pop more. But you can tolerate O3. Plus or minus O3, don't worry about it. For a gasoline engine that's running nominally stoichiometric, an O3 difference here isn't going to make any difference in the accuracy of the AFR sensor worth worrying about it. There's other issues to worry about. It's so small. On diesel engines, it's most critical during low loads when you're at like 50 to 1, and a plus or minus 0.03% O2 is 0.14 air-fuel ratio error. That's a very small number at a diesel running 50 to 1. So I'm just going to reset again these things. Okay, let me tell you about the traceability, talk about a bit about the traceability of the calibration. The Lambda sensor is a device that measures a gas composition and reports that composition as a current, which is called IP1X, which you can see down here for node 010. And if you go here under module, you can look at the IP1X current for any of the 4 sensors that are attached. So the calibration of the sensor requires an accurate knowledge of the composition of the span gas, which here is air, and the ability of this module to measure that current. So the accuracy in the knowledge of the span gas is determined by the accuracy of our knowledge of the humidity, which is determined by this barrel can module. The sensors that are used by the barrel can to determine the humidity and therefore calculate a correct actual O2 is this sensor up here, which measures humidity and temperature, and this one down here, which measures pressure. This pressure sensor here is used by the Lambda cans to do the pressure compensation in case you're doing this calibration at different altitudes or different barometric conditions. It normalizes that out. Now the ability of the Lambda can to measure the currents is checked using this sensor simulator in here. So this sensor simulator is a precision current and voltage source, which will simulate, for the case of the current, the sensor, and for the pressure sensor, it will simulate the voltage. So these sensors here and this simulator ensures you the traceability of this calibration. And you typically will send these back to us to have them calibrated or the calibration checked once a year. We recommend that you use this sensor simulator to check the ability of these 4 modules, the Lambda CAN modules, to properly measure current and voltage. Now I'm going to explain how to use this Lambda O2 sensor simulator, which also simulates the pressure sensor. And you use it to check the ability of these 4 Lambda CAN modules to measure the current from the Lambda sensor and the voltage from the pressure sensor. You follow the instructions on the back. Okay, turn off Lambda CAN and sensor simulator and connect the cable. So I turned the power off already. I disconnected this cable and I plugged it in. Turn on Lambda CAN and wait 2 minutes. You might not want to wait 2 minutes, but whatever. All right. Verify error code OX00. Well, these lights, the green lights are on, and what you do is you select under module, you select, we're connected to OX10, and then you look down here under error, and we have no errors. Now check that module temperature is 30 degrees Celsius. So you pull down this menu, this here, and you go to find temperature. There it is right there, temp. There's 33. plus or minus 5 degrees. Well, we're within specs. All right, the voltage input should be between 11 and 28. V switch, so pull down here. VSW, there it is, 28. You're not going to have these problems with this setup because of the power supply we use, and you're going to be doing it in a room, but in case you're using this calibrator on a vehicle out in the snow. All right, so you're going to be looking at IP1X and P volt. And so what you do is you turn this to settings. It's at rich for lambda and P1 for pressure. And it says here rich, it should be minus 2.022 plus or minus 0.1. That's well within there. And for P1, the voltage should be less than 0.5. It's less than that. And you go to stoic. And it should be, takes a while for the averaging to come in. So it's going to go to 0. And the P volt is clicking to 1.267, 1.267, well within the 0.1, 0.05 accuracy requirement here. Do it to lean and P3 for pressure 3. You get 957, and it should be 956, but you can change it to 966 would be okay, so it's well within the spec. And the pressure is within 3/10,000 of a volt of the target. And the last one, you go to air. The air is 6.0 milliamps plus or minus 0.1. It's 0.02, so it's 1/5 as good as better than that. And again, the voltage is 466, so it's a fraction of a millivolt to within the specification. So therefore, this device is capable of accurately measuring the currents and pressure of the voltage of the pressure sensor. This you only need to do once a month, and frankly, in units that are used indoors and dynamometers, you don't see these things drift a lot, but we recommend you do this once a month. In vehicle applications or where there's a power supply blowing up or something weird happened, the cable got burnt, and you're just wondering the health of this unit, this is very handy unit to use. So in this case, you could check all 4 of them. I hope this tutorial has helped you in understanding how to use the Lambda sensor calibration system. If you have any questions, you can either call us here with the telephone number or go on our website to find an email address to send us questions for support. Thank you.